All right, so this is our intro into stretching and shrinking. So first thing that we want to do is we want to copy down some definitions. A shrink is a transformation that decreases the height or width of a figure, and it's created by multiplying by a scale factor of less than 1. So that's pretty important. So it's less than 1 for this. Our scale factor is less than 1. Our stretch is a transformation that increases the height or width of a figure, and it's creating by multiplying by a scale factor that is greater than 1. So this one would be greater than 1. So down here you can see that if this is our original figure, our vertical stretch is making it kind of move up, like it's increasing in height. It's getting skinnier almost. And our vertical shrink is making it kind of fat and short and stubby. So to find the equation of the function shown in this graph. So this is all based off of that. Wow. This is all based off of our parent function, y equals x squared. So this isn't that graph anymore, right? So what we want to look at is first is our vertex to help us. And I see here that normally it looks like this, right? I'm going to do that in black. Here's my vertex. Here it is, up 2 over 4. And it's something like this. That's our original graph. So if I look at my vertex, it was at 0, 0. It's now here. So it moved to the left 4. And I represent that in the parentheses by going x plus 4. That's where it's the opposite. So since horizontal, like your x movement goes inside, and it's the opposite. If it would have been right 4, that would have been my minus 4. And there's my square. And then if I looked, it's at 0, 0, and it moves up 2, right? It went up 2, so that's going to be my plus 2. So right now I have this. Y equals x plus 4 squared plus, plus 2. But there is some sort of stretch or shrink here. There is a stretch or shrink that I'm going to put out front of this. I need to put a number there. So if we look here, and let me change my color, red. Nope, that is red. We'll go blue. I normally went over 1, up 1. But if I look here, when I go over 1, I don't hit until right about there. So I go over 1, up 1. I went over 1, up. That's about 1.5, right? So I went over 1, up 1.5. That's for that first one. The second one I'll do in green. Second one here, we go over 2, we went up 4. So here we're going to go over 2, right? 1, 2, but I'm going to go up 1, 2, 3, 4, 5, 6, right? So I'm going up more now. It's different. I'm hitting at about 6. So this one it would have been 4 that I should go up, but I go up 6, which gives me 1.5 over 1. So I want to compare it to what it was. So this one was a 1. That's how I got that one. And I went up 1, right? I went up 1. Here I go up, that's about 1.5. That's where I got that 1.5. Here I go up 4. That's where I got that 4. Here I go up 6. That's where I got that 6. If I simplify this, right, they both divide by 2. 3 over 2. 2 goes into 3 1.5 times. They should be the same number. So I'm just looking at what they both go up by, making it into a fraction. Here's the original. That would be like my parent function. This is my new one. My original went up by 1. My new one goes up by 1.5. My original one, the second point, goes up 4 here. My second one. This one went up 6. Simplify it, you get 1.5. So my final equation then would be y equals 1.5 times x plus 4 squared plus 2. Your vertical or your horizontal stretch is always out front. So just say that the vertex didn't move. It could look like this. Y equals, come on. Sorry, my thing is freezing. Y equals 2x squared. If I had this as my equation, that means that my vertex is still at 0, 0 because there's no parentheses, plus or minus, and there's no nothing at the end. It's just showing me a vertical stretch since it's greater than 1. I also could have had y equals 1/2 x, which would show me a shrink. So when you represent a stretch or a shrink, it always goes outside of whatever your squared term is here. This one, it's by itself. Here, my squared term is this whole thing, and it's outside of that.